I guess we'll get started. Okay, so today we're going to talk about 3 protocols. So I got an hour to talk about it, each 20 minutes, roughly around. MCP, ACP, A2A. So these are the 3 protocols that we're going to be speaking about today. My name is Taswar Bhatti. I work as an AI security solution architect for Microsoft. Okay, so most of you might have seen this XKCD on protocols or like standards. Basically, there's 14 competing standards. That's ridiculous. We need to make a universal standard, and then you end up with 15. So if you look at all the protocols that are there for agent to agent, it's like, it's not 15. There's like hundreds of them right now. We are just kind of focusing on 3 of them today. Okay, so what is an agent? Sorry, let me close this. What is an agent? An agent is a specialized AI assistant program of some sort. Like from my perspective, an agent is, I don't see it any different than a program of anything. It pursues goals on behalf of its consumer. It has some kind of data source that it interacts with. It performs certain actions. It may need a certain context. So if I really think about it like AI agent, I look at it as more of a Linux mentality, where in Linux, if you type in ls, that's all it does. It doesn't do anything else. It actually just does a, let me just turn on my Teams, maybe. Too many messages coming on. Teams. Sorry about that. Quit Teams. There we go. So, as I was saying, if you look at ls, it only does ls, and if it does, it doesn't do anything more. That's what an agent is supposed to be doing. And if you look at word count, WC or something like that in a Linux command, it only does that. Or if you're into Windows, dir, that's all it does. It doesn't do anything more. So it's a program of some sort that actually just does certain actions. But now agents are more related to LLMs. So here's a sample agent. This is in Microsoft Agent Framework. So it's in C#. It's a very simple agent. I'm using a URL resources pointing to where my model is. I'm using some Azure CLI credentials, and I'm pointing to the model that I'm going to be using, GPT 4.0 mini. And when I'm creating the agent, I'm giving it some instructions, telling it, you are good at telling jokes. And then all I'm doing is actually running a chat with it of some sort, telling it, tell me a joke about a pirate. That's all I'm doing. So if you want to use this, you need to add the .NET package, NuGet package with Microsoft.agents.ai. And if you're using Python, you would use UV pip install agent framework. So it's kind of the same thing. That's a sample agent in C#. Now, you guys probably heard today a lot about MCP already. Now, when you train an LLM, there's a model that you train it that only knows about knowledge of certain things that you train it with. It doesn't know what the weather is today in Manchester. So in order to provide any extra functionality, you would actually create something called a tool. So a tool is as simple as just a function call to say, okay, do this kind of thing. These are the extra functionality that you could actually use as tools for the LLM as your agent. So here you could see, like I've created a single function that says get weather. It always returns 15 degrees. And that's all it does. And what I've done, and if you look at the lower corner, you'll see that I've created the agent, your helpful assistant, and here I'm providing it the tools, saying get weather, here's a tool for you that you could potentially use. So what really happens? Now I've tried to get weather, but if you think about like if you have a large organization, you might have different development teams. They're all building some kind of an AI agent. They have their own custom implementation. They might be using different frameworks, Crew AI to any LangChain, to anything else. They might have their custom prompt logic. And then they might have their custom tools that they're calling. But it could be common tools that you're calling. So if you're working for financial services, maybe, you have the financial services API that's being called as a tool is done this way in one team and the other way in the other team. So you could see there's a lot of code that's going to be common in some ways, but used differently. So that's where the fragment actually starts to begin. And basically what happened is Anthropic came out with a solution for this. They called it MCP, basically Model Context Protocol. And I would say that it's a standard way of how, like if you look at APIs, it's a standard way of how to actually talk to a backend, servers, databases, or services. MCP is a way to actually talk to AI application, and all it provides is three things. One is prompts, two is tools, three is resources. Those are the three things it provides. But I could tell you 99% of what we're actually seeing these days is tools that people are using it for MCP. And when I look at MCP, it's about services, consuming services. So as an example that I was saying, get weather, the weather is a tool that I potentially could use. So what are the key participants of an MCP? There's always the MCP host. That's the AI application that coordinates or like has multiple MCP clients. It has an MCP client. The client is actually the one that actually talks the MCP protocol to the server, MCP server. There needs to be a server too, a program that provides MCP related to the client sort of thing, responding it. And the server usually is connected to some kind of a data or some kind of resources or services, I would say, that you need to return to the client. Here's a diagram of explaining it. Your host could be Claude, could be VS Code, could be an IDE, or could be your Python code that you're actually building in your VS Code. And then you create these clients, MCP protocol clients. And in those clients, you would connect to the server. And the servers might be connected to your local data source or some other local data source. Or it could be calling a remote internet, remote services too, like get weather, as I was saying. So this is an architecture of it. So how does it work? I just played out a little bit around, like, how would Shakespeare say, how does it work? And that's the best it could get into. So anyways, MCP clients, again, resources, tools, and prompts. Those are the main things. And the server kind of exposes those three things to the client. And the tools that you could do is actually search for something, like get me the weather, or send a message. I could be saying that a tool that actually send a message to, it's like calling a function call or something like that. You need to send something, book something, or whatever it is that you need to do. Or you might want to update the records of something. Resources, again, it's usually read-only. So resources is usually read-only data that you actually get back. You might get back a schema of your database. Like, hey, what's the schema that you're using at the back? And it might give you the schema information. But usually it's only read-only. It's not like something that you could actually manipulate or do anything with it. And prompts are just basically a way of like telling, hey, how does this MCP server actually works? And these are the examples of prompts that you could potentially use. The communication, okay. What's the communication protocol of MCP? JSON RPC. So JSON RPC has all of this lifecycle management, server features, client features, utility features. But as we are in a security conference, there's no security in it. There's no authentication, there's no authorization, there's no TLS. It's just a protocol to actually just do JSON RPC. So then it becomes, what's the transport layer that actually this JSON RPC is usually carrying? So if you are developing for your local computer, you would actually use standard I/O, which is this, you want inter-process communication, because you want to quickly actually develop something, commonly used for MCP server implementation for like, hey, I just want two things to talk to one another quickly, no network overhead, I want to develop something really fast. And then there's SSE too, which is the server send events, HTTP. So in using SSE, you could actually, what MCP recommends you is actually using OAuth 2.1 for secure token-based authentication for the transport layer. And again, like if you're using, because when you're using HTTP transport layer, you could use your OAuth bearer tokens, JOT tokens, API keys, or custom headers that you might potentially want to use. So let's get started on a demo. Nope, not this one. There we go. Let me just zoom in. Right. Oops, too much. Okay, so here I am using Python, creating a fast MCP server called just demo. And the tools that it provides are very simple tools. It's just calculations. There's an add function, there's a multiply function, There's a subtract function. All it does is takes two parameters, add them together, multiplies together, or subtracts them, or basically divides them. That's pretty much it. And if you look at the resources, I don't have much resources. All it says is hello. You might say resources based on resource ID. Then it actually just returns back a JSON document, just dumps back to JSON. It's fake data, basically, just to for example. And then what I'm going to do is I'm going to run this as a server sort of thing. So if I run this, there's two ways to run this. Grab that UV run. Sorry. So this takes a little bit of time. This is more like a development server that actually it's going to pop up. So the development server, what it allows you to do is to validate all of that MCP stuff that you're building. If you want to test it out quickly and stuff. Sometimes it takes a little bit of time to actually launch. It's going to take like a minute maybe or so. Any questions so far? We're all good? You got enough of MCP today? Most likely. Everybody's talking about MCP. There we go. So here we are. So it launches an MCP inspector. So I'm going to connect to it. Hopefully it works. There we go. And then I could inspect on the stuff that I want to inspect. So I could say go to tools, and I say list tools. So you could see my add, multiply, subtract, divide. All of these methods are there. And I could say add 1 and 2. And I could run the tool. And successful. 1 and 0 it went. 1 and 0 is 1. So 1 and, let's see, run and 2, 3. So you can see it's executing on that server sort of thing. So this is like more like if you're developing something and you want to try it out, and MCP Inspector is a way to try out all the stuff that you want to do without creating a client or anything like that for it. So that's MCP server. But let's say I want to write a client. Then what? So here I'm going to start writing a client. So this client is very simple too, again. All it does is actually runs my server automatically for me. So you could see right here, I have standard IO server parameter. And I'm going to take the standard IO server, async it, read and write stream. I'm going to initialize the session. All I'm doing is like from the session, I'm saying list me the tools. What are the things that I have inside the MCP server? So it's going to list me all of those. What are the tools that I have? And from the session, I'll actually call the add method and the subtract method. Like normally, you don't actually need to do this. LLM actually does that for you sort of thing. But this is a way for you to actually see, hey, if I want to build a client, how do I actually talk to it sort of thing? Maybe you don't need an LLM. Sometimes add and subtract doesn't require an LLM to solve the problem. I've seen that many times, like adding two numbers, ask LLM to do it. So let's try to run that too. Let me cancel this guy out. So first of all, standard IO, yep. So UV, oops, what happened? Windows. UV run. Why does it keep popping up? Is my hand touching anything? Maybe it's the mouse. Server, apply. Actually, I don't need to run the server because it's going to run it itself. So actually, I'm going to run is the UV run client standard IO. So there you go. Apologies for the small. So you can see it's running through it. Run through the file. It launches the server, and it's saying what is the available tools. These are the things. It's going to add 2 and 3, and 2 minus 3 is minus 1. So this is standard IO. Basically, it launches it. It's talking standard IO to itself sort of thing. So again, if you're building something, you could easily test it out. But what if I want to use SSE? So I'm going to change my server now to SSE using the SSE protocol. SSE. And now I'm going to run my client, no, my server. UV run server, apply. So it's running on port 8000. And now I'm going to run my UV run client. Before I show you, what is the SSE client doing, basically? So the SSE client, here's the host. Again, it's the same thing. It's initializing it and calling the same, pretty much the same thing. List tools, find me, all of that stuff. But rather than connecting it through the local host, launching the program and all that stuff, it is actually connecting it all the way from the SSE client. So that's the difference. So here, I'm going to run it again. So you could see from the other side, kind of like responded back. Again, same thing, available tools are add, two numbers, divide, and these are the two results that I wanted to call. So adding 2 plus 3 and 2 minus 3. So those are the two functions that I've called. So that's the MCP demo. Let's go back to my slides. Okay, so this is the famous joke, I think. S stands for security in MCP. So what is the best practices of using an MCP client or a server? Basically, you have to ensure that you have the confirmation settings within any configuration. These are the basic things that you actually normally do in your security environment too. Making sure that actually the model that you're planning to use is the model that you're using, that's for sure, and has safety limits that is built into it. And only use approved MCP servers. Like you know that you're going to be using GitHub, like when there's a valid authority behind it, making sure that that's the MCP server and it's provided, it's not github.com or whatever. Ensure the safety context and authorization. Again, always have authorization of some sort. So making sure that you have some kind of an OAuth that is protecting the MCP or the services that you're calling. That's the key thing. You have to, the normal protocol that you're used to, OAuth, just use your JWT tokens and pass all that information, and then like have a IDP. Actually, that's the next one that I'm going to talk about. If you know what an IDP, identity provider, you could use Entra to Keycloak. If you guys are using Keycloak, you could use Keycloak, or use Cognito if you're using AWS. All of these guys actually provide you with an IDP of some sort. You could use that. And this is the handshake that you normally see anyways. So the client makes the initial request and then get a 401. 401 actually tells it to authorize, gets to generate a session ID, gets a session ID back, and then puts it to the web. And the web actually calls the MCP server directly, exchanges with the IDP, like some kind of a key, some kind of access tokens, and then actually it caches that information and then returns a JWT. And from the JWT, you could actually continue passing the information on. You have a IDP that you trust that had provided you with JWT with the authorization and authentication that you want to do. Then you could call the protected API or the MCP server that you're calling at the back. Now, sometimes you might want to use API management or a gateway of some sort too, because you don't want people to be calling your MCP server like crazy too. So you might want to protect it by using like some kind of API gateway too at the end of it, so that when people call it, it won't be calling you. You have some kind of a rate limit or something like that that you want to add to it. So those kinds of things come into play too when you're actually building your MCP server. If you're interested, OAuth's top 10 for LLM applications, a good read. Like what are the things that are actually for LLMs when I'm building applications for LLM? What are the things that I should be considering on? So how to build a secure MCP server? Show all text, the model, not just the UI sort of thing. Log everything. Use the version pinning. So if you have a version of an MCP server, use the pinning, reliable tools that you're going to be using. Minimize the rights, least privilege. We know this. We're in security conference. Least privilege for tools and agent. If you don't need the access to it, don't provide the access to it. Log regularly, audit all the prompts and manifest. Strong authentication, never share tokens. Never blindly trust hype tools. And prompt shield, basically. If there's a prompt shield of anything that could provide you before the LLM, please do so. To filter out anything that could be malicious or even like children unfriendly and stuff like that. Make sure that actually all of that is protected from the LLM to any agent that you build. So key resources, if you want to take a picture, here's the MCP official website, MCP for beginners, although you probably are like choking on MCP today. Here's a bunch of MCP videos or guides that you could actually take. MCP server from Microsoft on GitHub. remote servers, and there's a dev days too, actually, for MCP. Cool. Done. MCP over. Whew. How many minutes are we in? Okay, we're in good time, actually. Agent-to-agent protocol, A2A. Okay, A2A, MCP, both are protocols. Both are related to agents. Both have clients and servers. Both use JSON RCP. So why do we need multiple agents, basically? Agents, as I mentioned earlier, sort of thing, works best when they focus on a specific goal. Just like how I mentioned earlier, Linux has a specific goal for each of the commands, ls to the world count to grep, and all of these just does one thing and does it very well. So try to focus your agent into one thing it does very, very well. If it's done very, very well booking airline tickets, that's all it should be doing. It shouldn't be actually booking your hotels. Maybe you need another agent for booking hotels. Maybe just for flights, that should be a separate agent. So when you're asking for an agent to do too much, you're overwhelming it. You're overwhelming the LLM too at the same time, and poor outcomes. So I don't know if there's any Simpsons fans or something like that, but I remember this episode where Homer had to build a car, and he built like a space truck kind of a car that actually has everything that it does. Don't build your agent like that. Just build it like that it actually does one functionality. You can have multiple agents. You don't need one agent. So again, overloading an agent with MCP tools could lead to poor performance, basically, poor performance. Multiple agent has a complex kind of a goal using specialized agents. So again, if you look at the agents, consider travel agents like how I mentioned earlier, booking a flight, hotel, or organizing excursions. So those are all different agents that actually you would want to use. And MCP, again, as I mentioned, is prompt, tools, and resources. And you can use MCP for agent to agent. So how is MCP going to talk to a booking agent or a hotel or an excursion agent? That's not going to happen, sort of thing. So MCP is good for those three things. But actually, what actually happens is MCP and A2A works hand in hand very well. So when you think about MCP, think about agent to services. I need something. Then I need to actually talk to a service. I need to pull out all my GitHub pull requests, or who has committed what sort of thing, and analyze that. Then you're calling an MCP server to feed it back to your LLM, and then to analyze all of that stuff. That's possible. But when you talk about agent to agent, then you're talking about A2A protocol, where it's like, hey, I want to call my hotel booking agent to book me a hotel. Or I think you guys have TUI2, the agency or something. Let's say that your company actually uses that third-party vendor for something for booking stuff. Then they might have these kinds of agents, actually. A couple of agents that you might want to call. And you might build your agent that might actually call these agents. So again, agent-to-agent protocol is a standard. Again, Google came out with it. But it's an open standard, and it's not just Google. There's many, many companies that are to it. It's not just an SDK, basically. It's more like a protocol of how actually agents should be talking to agents. Microsoft's are also part of the working group for the protocol. And an example of it, you have an AI assistant agent that you're building, so it might actually book a flight booking agent. It might have a reservation agent for hotel reservation, currency conversion agent. It might have a local tours agent, or maybe a language agent that actually tells you how to say hello in Spanish, like if you're planning to go to Spain or something, or Turkey, where I'm from. And Google Cloud, basically, is the one who actually came out with the agent-to-agent protocol. And you can see there's a lot of companies actually supporting it. And the last protocol that I'm going to be talking about, it's going to be related to it too, the ACP. So let's jump into the A2A agent details. So an agent, what does an agent have? An agent has a card. So a card tells who I am, what kind of agent I am, an assistant who could help you with a variety of tasks. What do I do? What kind of things can I do? I could answer questions with things that you need to get done. How do you authenticate to me? So what kind of credentials do I require? And what's my endpoint? So this is in a well-known agent card.json. So there's a format for it. It's in JSON. And it tells it like, hey, you know what? I'm a travel agent, travel booking agent. that has this URL, this is my URL, these are my security schemas, I need an API key, blah, blah, blah. And if you look at the right side, that's my skills. What can I possibly do? I am a travel agent, booking agent, but you can see, organizes a luxurious hotel experience, including flights, hotels, and restaurants from Perth and Sydney to Hawaii. Nowhere else. Like, that's all it does. It doesn't book anything else, that's all it does, sort of thing. So it also gives you examples too, saying that book me an amazing holiday to Hawaii from Perth. I'm turning 50 this year. I want to eat like a royalty at Maui. Can you help? Like these kinds of things that you could actually provide to it. And actually, it will be able to give you the information. So the agent card kind of like it's almost like a name card that you're giving to a person, but it gives them more, hey, what are your skill sets? I might be a Python programmer or a C# programmer and I live in Perth. I don't know. Just coming out with stuff. So the protocol, again, JSON RPC, the friendly one that we saw for MCP, gRPC, HTTP REST JSON. So those are the request response and streaming that it supports. So again, the RPC protocols has like the message stream, the streaming of information that you're coming back and forth. You can send it a message and call it for a webhook to come back later on, because you never know how long that process, the booking of a hotel might take a longer time. It's not like a 2 seconds thing that it's going to respond back. It might take like 5 minutes later that it's going to come back, analyze what is the cheapest, what are the best options for you. You could also cancel the task, because you're actually kind of sending it a task to do. You could resubscribe to the task. So again, it has the callback to actually call you back later on. So, again, as I said, the call could last for seconds, months, or years. I hope not years, because nobody's going to wait for that long. So again, there's a SSE to call you back with the webhooks too at the end of it. Here's a diagram of it. I don't know if it's. Let's see. So here's a client, agent discovery, that's trying to see, get the agent card, returns the card, and then authenticates with the security schema, returns back a JOT token. Oops, sorry. Let's zoom in. And then sends a message to it, and a streaming message too, basically, at the end of it. Sorry, just went too fast. Okay. So how do we build an agent? In A2A, an agent is very simple. An agent is defined as, it gets a little bit more complex. This looks very simple, but it has multiple layers to it. So the crux of it is the agent that you're going to write, hello world agent. It has an invoke function. That's pretty much it. Whatever needs to be done, it's calling the invoke. So here is a hello world agent. All it does is returning hello world. That's all it does. So, but to get the concept of it, hello world is the best concept. And then you got an agent executor, basically. So this is the hello world agent executor. It initializes, you could see in the init method, in the constructor, basically it defines a self.agent and creates the hello world agent. And then it has an execute. The execute is the one that actually puts it in a queue and then tries to actually execute the agent by invoking it and get back a result. And there's also a cancel too. So you want to cancel whatever was being done was taking too long. So there's the agent executor, which wraps the agent. There's also an agent skill that you have to provide. Like, what is the skills of the agent? Hello world, it returns hello world. Examples, hi, hello world. Those are the things that you want to provide for it. And then the agent card, the skills was one thing, what can I do possibly? And then there's also agent card. How do you actually reach to me, basically? Here's my port, and here's my skills. Here's my authentication that you might want to add to it. These are all basically part of the agent card. So here's the other wrapper sort of thing. So you have the executor. Now you need to actually execute. The executor does not have a port that needs to run, right? So you use the default request handler and using an A2A's Starlet application, wrap that all around so that it provides a port for it so they could run the executor. The executor could actually launch the agent that you want to run. So again, here's an example of it. So you got the A2A agent calling the server, discovery, get back the card, retrieval, and then sending a message. Zoom in here. And then calls the hello world agent execute, invokes that method, generate hello world going to the agent, and returns back the results, basically. And then you could stream those chunks of messages too, if you want to, basically. I think my mouse is moving, that's why. Sorry. So, again, here's an example of it. For example, that I have an A2A agent that is currency exchange. Here's my skill. I could get exchange rates. I could, what are the tags and like what are the example? What is the exchange rate from USD to euros or to pounds? How much is Japanese yen won to US dollar worth today? So again, you would just build these kinds of agents that you could potentially call to actually find out the information that you want. So let's do a demo of A2A. I'm a big Simpsons fan, sorry. So my agent, which is going to be, it's actually going to be 3 agents running together and talking to one another. So there's going to be a Alice agent. So again, what does Alice do? So this is a number guessing game, basically. So Alice just basically chooses a secret number. There's Bob and there's Carol. These are the 3 agents running and talking to one another, basically. So the Bob is the UI sort of thing. Bob is the one that actually enters a number, and Alice is the one that actually has the secret. So it has the number that you're guessing, and Bob is the one that, hey, is it a 5, is it a 10, or is it what? Carol is the one actually who shuffles the things, shuffles it around and sorts it out. Hey, these are the ones that you have chosen so far. So we have to launch 3 of these agents together. Again, like, I mean, you could see it's the same kind of a thing. There's a skill, there's a dictionary that you have to provide. So they are all running in different ports. So if I look at my config, so you could see one is running 8001, one is running 8002, one is running 8003. So there's 3 of them that are going to be running. So let's start with Alice first. Hopefully my mouse does not do weird things. Python, agent Alice. Let's see. Environment. Activate. There we go. Okay, so now I've got Alice running, who could generate a number. Now I need to actually run my samples again, so I need to cd into samples, number guessing. Let me activate my environment. So environment, scripts, activate. Now I'm going to run agent Bob. So that's the number one, and I'm going to run the Alice over here. No, Alice and Carol. So samples, Python, agents. Let me activate the environment. Python, Carol. Okay. So you could see in the middle part, I'm saying guess a number, right? So let me clear this out, a little bit bigger. I'll just go with 50. So Alice says go lower. So you could see the messages are going back and forth in between them, sort of thing. Alice says go lower, so, and then your guess. So Alice is the one that actually does it, but you could see on the right, which is Carol, Carol kind of shuffles it. It got 50 at the beginning. So if it's going to go lower, let me try 40. Again, it's going to go lower, sort of thing. So now you can see that there's 50 and a 40, so it's shuffling between the 2 numbers so that it's ordered in a way that I could see it, sort of thing. So it's almost like a assistant let's put it this way, like a handy little assistant. Carol is just there to showcase the fact that actually there could be an agent that is doing something else to provide you with the extra work that you want to do. So I'm going to say 20, let's see. Again, go lower. 10. Go lower. So now you could see actually shuffling around on the right-hand side, saying 10, 20, so it's got to go lower. Let's say 5. Go higher. Try again. It's going to try to shuffle all those numbers together. But you guys get the idea, basically. One agent could talk to another agent could be doing something for you, and then get back to you the sorted list of something. I mean, you could sort it yourself too, but it's just an example of like, let me just try 8 last time. Go lower. Okay, anyways. But that's the way A2A agent actually talks to one another. All these examples are actually right in the, you could go to GitHub and actually get them. A2A samples from Google, you could actually get all of that stuff. So let's talk about the resources. So if you go to A2A protocol, that's the official website. There's also the Microsoft intro blog to it, aks.ms/A2A. There's the technical community blog for A2A in AI Cloud Foundry. If you use A2A in Semantic Kernel or Microsoft Agent Framework, those are all basically in there. Those are the resources. Okay, so the last protocol that we're talking about is ACP. So the nice thing about ACP is actually, finally, they joined forces with A2A. So that happened August 29th. But I still want to mention ACP because they did some stuff too that was actually kind of like, it's going to help too in some ways. So what is ACP? ACP is an open standard developed by IBM. So IBM came up with it, and it's currently under Linux Foundation governance. So that's why after it went to Linux, so they were like, hey, you know what, this kind of protocol should make sense for A2A too, let's make it into one. Remember the standards thing, that's KCD? Kind of the same thing. The main thing about ACP, it solves interoperability challenges by providing like common language for AI agents to exchange stuff. So actually, to tell you the truth, ACP is kind of like the REST API that we know of. Because at the end of the day, you have a microservice. You don't care if it's written in Python, Go, Rust, or whatever that language you want to call. As long as a REST interface, I'm going to be talking to it. ACP kind of went with that mentality of like, hey, you know, you might have multiple agents that are done with different frameworks, LangChain to Crew AI to anything else. They should be able to chain to one another and like be able to answer certain things. So again, it enables collaboration across frameworks. So how does ACP work? Again, client-server model that we know. Client-server model that we know quite well. It sends a request, and the server basically responds back the result for it. It's a RESTful API call using JSON RPC again. Core components, there's an ACP message, there's a task ID and a metadata, and there's a discovery, basically. So it looks at the dynamic lookup, and there's a workflow kind of example where agent A could delegate tasks to another agent within the agent framework sort of thing. So it might actually say that, hey, you know what, translate this and then write it into this document or something like that. So you could do all of that stuff with it. So again, the main thing about ACP is interoperability and dynamic discovery. There's a stateful session kind of built in. So it's what we know, basically. If you look at client server, we usually have a stateful thing that we need to show shopping cart IDs and all that other stuff. It's the same kind of idea that they have used. The security, the cool thing about the security is actually integrated with Kubernetes RBAC. So they went with like having Kubernetes and all these other stuff built into it when IBM started it. And then like observability too, basically, monitoring and debugging. How are we doing with time? Yeah, we're okay. Okay, why MCP for ACP for enterprises? Scalability. We already know this architecture sort of thing. Easy to add and replace agents without rewriting systems. Use cases, multi-agent orchestration for complex workflow. Might be more complex, not like, but as you can see, ACP and A2A are kind of combining forces. Cross-company collaboration, and there, you could create a market space for it too. So let's do a quick demo of ACP2. There we go. So So this ACP, let's look at the agent first. So when you write an ACP server, there's always a server that you actually provide where it's going to be hosted, sort of thing. And then there's a server.agent where you actually put the attribute of it. So this is the approval agent. And all it basically does is the action that it could do is like it's messaging, basically, passing messages. I can generate a password for you. Do you want me to generate a password? It's going to wait for a user to actually, a client to actually say yes or no, sort of thing. So you could think of like certain flows of an agent. You sometimes require human in the loop. So this is sort of an example of a human in the loop within calling, if there's an LLM in there that, hey, I've done this. Should I continue or not? Please let me know, sort of thing. So this is an example of that. So all it does is actually generates a password, random passwords of ASCII strings, or it basically says declined of generation of passwords. And if you look at the client again, here's the client. It's going to connect to a URL of some sort, HTTP URL, which is 8,000 over here. And then it's going to send a message to it, say, hey, can you generate a password for me? And then once it gets back the events that is coming back to it, sort of thing, it's going to try to actually put the event human in the loop, getting an input, enter yes or no, sort of thing. And then it's going to send that message back to the server, basically. And here's where the message is being sent, handle resume, and the result is being passed back to the message. So let's run this. So I hate when it does this. Let's see if it's going to run it. Come on. Agent. Nope. Where's the environment? Maybe I should try this. I'm running another agent somewhere, probably. I gotta cancel these guys. Let me jump back. What is running the 8,000? It's over here, actually. Sorry about that. I think as programmers, we got used to the 8,000 and all that. Okay, so the server started, and I'm going to jump back into the Python basic. Right. So here I'm going to, let's clear this off first. UV run client.py. So here, like I've sent some messages to it, so it's waiting. You could see on the right side, the server is waiting for it. Here is asking me, hey, please enter yes or no. Do you want to generate a password or no? So I'm going to say yes. And you can see that it generates a password and sends me back, your password is blah, blah, blah. So I could try one more time. Going to run another. And I say, okay, no, I don't want you to generate me a password. And then it's going to get back the message, password generation declined, basically. So just so you know, I'm not making this up. We're running one more time, and I'm going to say yes. And you can see it's a different kind of a password, sort of thing. So again, it's a client-server protocol that we're kind of very used to it. And you could chain all of this stuff to actually, for example, I'll show you another example. Story writer. For example, there's an agent. So there's multiple agent. Here's an agent, story outline generator, does certain things, calls an LLM. And then there's another one, story writer using the outline. And then using the story writer, you could actually chain all of these stuffs together. And then from the client, basically you're saying that whenever I get back the input from the client, actually chain back to those agents. So here you have to provide a LLM to it, sort of thing. So you can actually write multiple agents. And the nice thing about ACP is actually it would actually handle that information for you and handle calling multiple agents within your server too, if you want to. Okay, let's jump back to the slides. So the comparison between these. ACP, MCP, agent to agent. Here's the table for it if you want to take a picture of it. Again, the strengths of ACP is tool modularity. MCP is best for tools calling. If you want a service, use MCP. For inter-agent negotiation, use A2A. The weaknesses, again, like, every framework has its strengths and weaknesses. They all do the best. Like MCP is really great for services. If you're consuming some kind of tools or services, use MCP. Agent to agent seems to be the most popular one. So if you're focusing on planning to use agent to agent communication, that you're going to build multiple agents, look into A2A sort of thing. ACP is sort of like getting into A2A at the same time too. So you could actually wrap around your ACP stuff into A2A also too at the same time. So they provide that kind of functionality. So that's pretty much it. I'm Taswar, and you could follow me on LinkedIn by the QR code if you want it. Multilingual, I speak quite a few languages, and I'm developer at heart, basically. That's pretty much it. Thank you. Any questions? No questions? Any? We're all good? Are we full from the lunch? Yeah. Yes?
The only one I've got, which isn't really to do with protocols, so it's not really quite fair to throw it at you, but people keep on using the example of booking an aeroplane
Yeah.
using an agent.
Yeah.
And then we consistently keep saying as well, you can't rely on an LLM to do the right thing. And it just feels like when you book an aeroplane, you want to book the right aeroplane on the right day, on the right time, etc. So it kind of feels like would you not be better off having a tool to book an aeroplane rather than an agent?
So the analogy, the question is basically, whether is it better to use a tool than using an agent to actually book airplane? The analogy for us to understand, usually it's the agent sort of thing. That's why the examples usually use booking a flight sort of thing. But I agree with you too at the same time. Like, when I started, I also said an agent is almost like a program at the end of the day. I see it as like a simple program that actually could do something. Now, I could see the power of, for example, I'll give you an example.
Agents playing a game was a really good example where you've got that collaboration between the agents, haven't you?
Yeah, so that's kind of, so what I've done is actually I've chained multiple agents together to write me for not quite a blog post, but like a tutorial on how to do certain things like Power Automate, for example, in Microsoft. So Power Automate lets you automate all these stuff. And I needed to teach people how to actually use that to automate some of their tasks. So actually I chain multiple agents to actually write that document for me and actually throw in to say, make it more like Harry Potter style sort of thing. So it's able to do that. So with the LLM, it helps that. But if you're really talking about business to business things, sometimes I feel like the LLM could be like, there's a threshold sort of thing. Like how much can you trust it and not trust it sort of thing. So there's always any technology has a fine gray line sort of thing. How much can you really trust? I've even had booked flights using a tool and got canceled because of some whatever reason. Oh, it didn't go through, whatever the reason is. So, technology is technology at the end of the day. I don't know if that answers you or not.
No, and I wasn't expecting an answer. Yeah. I know you're talking about protocols. It's just a discussion point, isn't it?
Yeah.
A thought point, really.
Yeah, cool. Any other questions? More discussions? Yeah.
During your example for MCP, the first one when it was doing just the adding that you made,
Yeah.
and then the second one was like guaranteed to do that result sort of thing that was put in. But the first one, was it just talking to a calculator service? Or?
So the very first one that I did was using the MCP inspector as a tool to actually showcase you, okay, if you have a server, you could just use a tool to figure out what it's going to be doing. The second one was the client using standard I/O communication. And the third one was actually using SSE, actually, communicating it like using a protocol. So for example, you could have your server to be somewhere else and then it's communicating it. Those are the 3 examples. Yeah. Any other question? We're all good? More coffee? Okay, thank you.